This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I'm going to talk about triangle congruence. And rather than just give you the rules for triangle congruence, I want to show you how you can derive them logically. So let's get started. I've got 3 sticks here. I'm going to take the sticks and arrange them into a triangle. Now, if you think about it, if you've got these 3 sticks, and their lengths are never going to change, there's really only one triangle I can make with them. If I had a second set of sticks and they had exactly the same lengths as what I've got here, I would end up making exactly the same triangle. This concept is going to give us what we call side-side congruency. What that says is this. If I've got 2 triangles, let's call one triangle ABC. And I've got another triangle. We'll call that DEF. And let's say side AB is exactly the same length as side DE, like 2 sticks that are the same length. So they're congruent sides. Let's say side BC is congruent to EF. It's like 2 sticks that are exactly the same length. And let's say that side AC is congruent to side DE. If we've got that situation where we've got 3 pairs of congruent sides, then those 2 triangles are going to be congruent. So this is called side-side congruency. Okay? Now, after that we have something called side-angle congruency. We can think of it this way. I've drawn 2 figures. One I'm calling ABC and the other I'm calling DEF. They're both made up of a pair of line segments that meet to form an angle. And angle B is congruent with angle E. AB is congruent with DE. It's exactly the same length. BC is congruent with EF. It's exactly the same length. Now, if I connect AC to form a triangle, I'm connecting it with a straight line. And I connect DF to form a triangle. I connect that with a straight line. Those 2 straight lines would really have to be exactly the same length because I've taken 2 identical figures and I've done identical things with them in drawing those 2 straight lines. So therefore, these 2 triangles must be congruent. This is going to be called side-angle congruence. I've got a side, a pair of sides that are congruent, and then an angle, pair of angles that are congruent, and another pair of sides are congruent. Now that angle has to be between those 2 sides. So these angles are called the included angle. So if we've got 2 pairs of sides that are congruent, and the included angle is congruent, then we've got side-angle congruency, sometimes just called SAS congruency. Okay? We've also got angle side angle. So I've drawn figure AB and figure DE. They both end in angles, angle A, angle B, angle D, and angle E. And then there's a line segment connecting angles A and B and connecting angles D and E. Angle A and angle D are congruent. Angle B and angle E are congruent, and the line segments connecting my angles are congruent. Now, if I take these angles, if I take the rays going off of angle A and angle B and extend them, they're going to meet somewhere. I'll call the place where they meet point C. And I'll do the same thing for the ray at angle D and the ray at angle E. And I'll say that they meet somewhere, and that's F. Now, once again, think about this. Figure AB and figure DE were identical. When I extended their corresponding rays, they must be doing exactly the same thing. They must be meeting in places corresponding places that are in exactly the same place relative to the rest of the figure. And they must be forming exactly the same angles. So that means these two triangles that I've formed, ABC and DEF, must be congruent triangles. So this is called angle-side angle congruence.